In this video, we are going to find integers x and y such that the sum of square roots of x minus root y and the square root of x plus root y equals the square root of x times y. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. My first step to solve this equation would be to square both sides. So by doing so, on the left we have x minus square root of y plus x plus square root of y. Furthermore, added by 2 times the product of the two sets. 2 times square root of x squared minus root y squared, and that's y. For the right, we just have xy. Simplifying, we have 2x plus 2 times x squared minus y equals xy. Then afterwards, I'm going to move the 2x to the other side. And so 2 times root x squared minus y equals xy minus 2x. Then I'm going to square both sides again, so then there will be no more sets on either side of the equation. 4 times x squared minus y equals x squared y squared minus 4x squared y plus 4x squared. And simplifying, we have minus 4y equals x squared y squared minus 4x squared y. And so we have x squared y squared minus 4x squared y plus 4y equals 0. Now at this point, I'm going to factorize the expression at the left because all terms have y as a common factor. So factorizing, y times x squared y minus 4x squared plus 4 equals 0. So either we have y equals 0 or the other expression equals 0, and we can write that as y equals 4x squared minus 4 over x squared, because there is only one term that contains the unknown y. I'm going to make y the subject. So now with two cases on y, if y equals 0, then going back to our original equation, we have root x plus root x. The root y in both terms vanish, and that equals root xy, so again is equal to 0. That means we have x equals 0. So one of the solutions will be x and y to be both equal to 0. Now for the other case, I can rewrite the fraction as 4 minus 4 over x squared. And I want this to be an integer because y on one hand is supposed to be an integer, so the other side, 4 minus the fraction 4 over x squared, is also an integer. So I want this fraction 4 over x squared to be an integer as well. That means x squared must be a factor of 4, and the number itself by nature is positive because it's a perfect squared, so it can only be 1 or 4. And that means x equals plus or minus 1 or plus or minus 2. And in each case, we have y to be equal to 4 minus 4 over 1, and that's 0. And for the other case, 4 minus 4 over 4, and that's 3. So now we have several solutions left for checking. Firstly, for the case when y equals 0, we know that that can only imply x equals 0, so we can quickly reject the whole case. Now for y equals 3, we can go back to our original equation. So we are looking at root of x plus root 3 plus root of x minus root 3 equals root of xy. Because we want all the terms inside the square root signs to be positive or equal to 0. And when y equals 3, which is positive, this x must be positive as well. So we can reject the case x equals minus 2. Cross away the minus sign, and that means the only candidate that survives at this point is x equals to 2 and y equals 3. So we can do the checking again. On 2 plus square root of 2 plus root 3 plus the square root of 2 minus root 3. So if I square this number, we can do the similar operation as before in our first step when solving this equation. And the square root of this expression is equal to 6. So that means this number is equal to root 6. And that means x equals to 2 and y equals to 3 is a valid solution pair. So xy is either equal to, both equal to 0, or x equals to 2 and y equals 3. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.